In the given progressive wave, one, what is A named? So we have this progressive wave and we are asked to name A, okay? So A is called the maximum amplitude, okay? This is maximum amplitude of the given progressive wave. So we have this. Now, second, if the wave travels O to A in 2 seconds, okay, find the frequency of the wave. So we are going to find the frequency of the wave. Now, when we look into this given progressive wave, okay, so we find there are 3 complete waves, okay. So we find this. So this distance is lambda. This is the first complete wave and this is the second complete wave, okay. So this distance is lambda and this is the third complete wave. So there are 3 complete wave and this is half wave, okay. So this distance is lambda by 2. So what you find? So I'm writing over here. We find 3 complete, okay, complete waves and 1 half wave. So we find this. Clear? 1 half wave. So we find this. Now, the distance OA, okay? The distance OA in term of wavelength, okay, is, so we need to add this, okay, 3 lambda plus lambda by 2, okay. So I'm writing over here OA equals, we have this lambda plus lambda plus lambda plus lambda by 2. So we get OA equals 3 lambda plus lambda by 2. So we get OA equals 7 lambda by 2. So we have this. So the distance OA equals 7 lambda by 2. So we have this. Clear? This is to be noted. So I'm writing, when the wave travels OA, okay, it covers length or distance 7 lambda by 2 in 2 seconds, okay. So this is given in the question, okay. The wave travels O to A in 2 seconds. Therefore, speed V equals distance by time. So we have V equals 7 by 2 lambda, okay, divided by 2. So we have this, clear? Because we have t equals 2 seconds, clear? We have this. Therefore, we can write speed V equals 7 lambda by 4. So we have this. Now, let us do simplification, okay? So we have V by lambda equals 7 by 4. And we know in general, okay, speed V equals F times lambda. So V, that is speed by lambda, is frequency, okay? So this ratio, okay, this is frequency. So we denote it by symbol F. So F equals 7 by 4. So hertz. So we have this. Therefore, frequency, okay, F equals 7 by 4 hertz. So we have this. So this is the solution of question 2, okay? Now, for 3, for A equals, that is amplitude equals pi, find the maximum particle velocity for given condition at 2. So we are going to use this frequency and we are going to put amplitude, that is maximum amplitude, A equals pi, and determine maximum particle velocity, okay, and concept, okay. Particle velocity, so let me write in this way, okay. To find particle velocity, we use this concept. Let's say we have y equals a sine omega t minus phi, okay. So we have this equation, clear? Now, when we put the value of omega and phi, okay, so we get this y equals a sine, and we know omega, okay, can be written in this way. So we can write omega in this way. Omega is twice pi f. So we have small t time minus, and we can write pi in this way, okay, twice pi x by lambda. So we have this, clear? We have this. How? We know, okay, let me do some rough work over here. We have this relation, okay, phase, this is phase phi, okay, this equals twice pi by lambda times path difference, okay. We are using this. So we have this in most of the text we find in this way, okay. Delta phi equals twice pi by lambda times delta x. So I'm simply writing in this way. And what we know, omega equals twice pi f, and we can write frequency f equals v by lambda. So if we rewrite this equation, okay, and this way, so I'm going to change frequency in terms of speed and wavelength, okay. So we have this twice pi f is v by lambda So we have t minus twice pi x by lambda. So we have y equals a sine twice pi by lambda is taken common, okay? So we get this vt minus x. So we have this. Now the particle velocity, okay? So I'm writing in this way. Particle velocity, let us denote it by symbol Vp. So this equals dy by dt. We need to take first derivative of this equation with respect to time. Then we need to find the maximum particle velocity. So I'm writing directly over here, okay? Solution of 3. Particle velocity Vp equals dy by dt, okay? And the maximum particle velocity equals amplitude A times angular frequency. So we have this, and we know angular frequency is twice pi f. So we have this. Clear? And let us put the value, okay? So from question, okay, we are asked to take A equals pi. So we are asked to take A equals pi. So A is pi. Clear? And we have twice pi. Frequency is 7 by 4, okay? So let me write in this way. This is 7 by 4. Therefore, we get 7 by 2 times pi square, and velocity is in meter per second. So we have this. So therefore, maximum particle velocity is 7 by 2 times pi square meter per second. So we are taking this, okay, for A equals pi. We are taking this condition, and we are using frequency obtained from second.